How does a heavy polar exploration vessel, recorded in 1848 as icebound and abandoned, end up resting upright and extraordinarily intact on the seafloor nearly 60 miles from the place history expected it to die? The total loss of the 1845 Franklin expedition stands as one of the most heavily scrutinized maritime mysteries in polar history. When the expedition initially sailed, it represented the pinnacle of 19th century naval technology, pushing deep into the uncharted Arctic. For generations, the accepted historical narrative dictated a very rigid, highly specific sequence of destruction. The primary vessels became locked into severe, impassable pack ice, immobilized against the winter, and were eventually abandoned by their surviving crews. The official naval record marked their final known coordinates, assuming that the immense, grinding pressure of the shifting ice floes ultimately shattered the heavy wooden hulls. History assumed the battered remains were sent to the bottom in a chaotic, scattered debris field. That timeline and that assumed loss mechanism remained the unchallenged historical standard for over a century and a half, until 2016. During a search redirected by local Inuit knowledge and a remarkable tip from Joa Haven resident Sami Kogvik, sonar operators scanning the freezing, desolate waters of Terror Bay located a massive acoustic anomaly. The target was resting at a shallow depth of roughly 80 feet. The sonar return presented a highly defined, unmistakably artificial structural profile. Its outline matched a three-masted bomb vessel with startling clarity. But the final identification came only after archaeological inspection, video review, and comparison with 19th century ship drawings. On September 18, 2016, Parks Canada confirmed the wreck as HMS Terror. The wreck's location created the central paradox. HMS Terror was found roughly 60 miles south of the heavily documented abandonment site, resting upright in shallow water with its wooden hull still largely coherent. That position and condition did not match the old expectation of a ship crushed in northern pack ice and scattered across the seabed. Remote visual inspections then added the detail that made the paradox harder to dismiss. Several hatches and windows were closed, while others remained open, pointing to a final condition more complex than either a crushed wreck or a perfectly sealed abandonment scene. The vessel may have been re-entered, remanned, or carried south by a process investigators still do not fully understand after the main abandonment recorded in 1848. It did not die in the expected northern ice trap. It arrived in Terror Bay under circumstances that remain unresolved. With the location verified and the structural condition confirmed as unexpectedly pristine, a new investigative phase was required to understand the timeline. However, the exact condition that makes the ship so valuable also triggers the heaviest possible restrictions on its access. This wreck is not a traditional maritime salvage target, but a highly regulated national historic site and a place of commemoration for a lost naval expedition. The protected area is governed through a strict co-management structure involving Inuit and Parks Canada, now evolving toward an Inuit-led National Historic Site. Inuit knowledge and local oral history were central to the discoveries, and in 2016 they helped lead investigators directly into Terror Bay. This jurisdictional reality establishes the hard limit on every investigative action. Unauthorized recovery, destructive entry, artifact removal, or structural alteration is forbidden unless specifically justified, permitted, documented, and designed to protect the heritage value of the site. The discovery proved the vessel survived far beyond the expected ice trap, but the next challenge was different, finding a technological way to read its preserved evidence without moving a single piece of the puzzle. The high Canadian Arctic gives surface operations only a brief and unforgiving weather window before the sea freezes solid again. During the short summer breakup, a survey ship must reach the remote bay, hold station over the wreck, and complete the diagnostic mission before falling temperatures close the route. A major mechanical failure, sudden storm, or unexpected cold shift could terminate the expedition with no practical margin for resupply. In 2019, the underwater archaeology team used that narrow opening to launch a dedicated surface operation. They completed 7 highly controlled dive deployments before the season closed. Once on station, the team also had to operate inside permit-driven boundaries that prohibited unauthorized interference with the protected structure. Environment and law now formed a single operational choke point for the project. Before attempting complex internal diagnostics, the survey team used the open water period to conduct a comprehensive exterior assessment. Sonar arrays and optical sensors swept the outer hull, building a precise three-dimensional model of the surviving structure. The mapping confirmed that the heavy wooden timbers and specialized iron bow sheathing remained remarkably coherent, while also identifying potential entry points and structural vulnerabilities from a distance. It established the crucial structural baseline for the next phase. Exterior data was only the first step. The highest historical value lay inside the dark compartments. The engineers now had to move from wide area mapping into a precision survey of confined interior spaces without creating access. They could not remove bulkheads, force sealed doors, dredge pathways, or clear blocked openings. If structural debris or a securely fastened timber hatch closed a route, that route was closed to the investigators. Together, the short season and the no-contact requirement forced the next phase into an entirely remote, hands-off approach. The team had the coordinates and the exterior map, but a heavily equipped human entry was the wrong tool for this stage. The method had to pass through existing narrow openings, project vision deep into the lower deck, and leave no trace. The most viable method was a small, remotely operated vehicle, chosen because it could pass through existing openings without forcing new access into the historic structure. But once inside a submerged, enclosed 19th century ship, the machine introduced a severe engineering constraint: the tethered spatial limit. Every remote vehicle had to trail a physical umbilical back to the surface ship for high-definition video and real-time piloting commands. Inside the extremely confined spaces of the historic wreck, this tether represents the primary hazard to the site. It is a long, continuous line that constantly threatens to snag on splintered timbers, wrap around structural pillars, or drag heavily across the fragile decking. The operational mandate strictly required that the tether must not strike any displaced objects or alter the resting state of the internal architecture in any way. The pilots operating the vehicle from the surface ship had to manage every turn with extreme care. They had to account for the umbilical drawn into the vessel and control its tension throughout the survey. If the tether snagged on a sharp wooden edge or disturbed a fragile historical artifact, the mission would risk violating its fundamental non-disturbance objective. The team guided the primary microvehicle down through an open main deck companionway, its lights cutting into near-freezing, pitch-black water. From the surface, pilots threaded it through the lower deck by advancing slowly into corridors and narrow 19th century doorways, then reversing along the same physical path so the umbilical would not loop back on itself. By that method, the vehicle explored exactly 20 distinct interior cabins and enclosed compartments. This precise internal navigation produced the next objective gain: a detailed visual record of the lower deck, crew spaces, and preserved internal layout. Earlier inspection had already identified the wreck as HMS Terror through archaeological review, ship drawings, and key external features. The new interior imagery strengthened the structural record without requiring physical contact with the historic fabric of the wreck. During the internal mapping phase, the team recovered no artifacts from HMS Terror. The survey demonstrated that optical sensors and careful spatial navigation could extract substantial historical data while keeping the protected wreck physically undisturbed. The micro-remote vehicles had solved the tethered spatial problem well enough to map the lower deck and establish a baseline condition for the crew spaces. But as the cameras reached the officer spaces at the stern, spatial control was no longer enough. The sensors encountered a different barrier, one no amount of careful piloting could bypass. In the stern gallery, the cameras recorded a preservation scene that seemed to defy every expectation for a 19th century wooden ship submerged in Arctic water. Some window glass remained in place, directly exposed to cold, dark seawater and decades of sediment. Those thin panes strongly suggested that the main hull had not suffered the violent, crushing event once assumed in older accounts of the ship's loss. Nearby compartments added the strongest interior evidence. High-definition cameras recorded ceramic plates, glass bottles, and delicate stemware still resting upright on their original wooden storage shelves. Heavy wooden desks and sleeping berths remained fastened in their designated positions. The objects had not been thrown across the compartments or crushed by collapsing overhead decking, showing that the hull retained internal integrity until it flooded and settled on the bottom. However, the exact same slow, undisturbed water flow that protected the delicate glass panes also triggered a profound investigative barrier inside the primary cabin. Over many decades, extremely fine marine sediment seeped through the stern gallery windows. Because the deep water enclosed inside the cabin was still, this fine, particulate matter gradually dropped out of suspension. It systematically settled over the primary historical target of the entire expedition, the heavy wooden desk belonging to the commanding officer. This slow, continuous accumulation created a thick, low-oxygen sediment blanket over the central furniture. This dense layer of silt effectively sealed the workspace inside a protective underwater vault. For underwater archaeologists, that sealed, low-oxygen environment matters because it can slow organic decay. Paper charts, personal journals, or official ship records left on the desk or inside closed drawers might therefore survive beneath the sediment. But the same blanket that may protect fragile paper also hides it from visual confirmation. That dynamic created the local proof ceiling for the survey. The vehicle could approach the commander's desk, but the cameras could not verify what lay beneath the silt. Under the non-disturbance protocols, the pilots could not use thrusters to blow the sediment away, brush the desk clean, or force open sealed wooden drawers. The possible written record was preserved within reach of the lens, but beyond the permitted reach of the mission. The coherent interior evidence answered one question. The lower spaces survived in an extraordinary state of order, but the sediment barrier kept the possible written explanation out of sight. To understand the mechanics of the foundering, investigators had to turn away from the preserved cabins and examine the exterior geometry of the ocean floor, especially the structural evidence that was missing. The most critical physical clue to the foundering was the scattered structural debris field that did not exist. If the vessel had been catastrophically crushed by shifting ice before sinking, investigators would expect a chaotic forensic signature on the seabed: torn hull sections, splintered cross timbers, detached rigging, and fragments spread away from the main wreck. High-resolution exterior acoustic mapping did not reveal a wide, chaotic crush field around the hull. The key absence was not every fragment, but the broad destruction pattern expected from the old image of a ship shattered by ice before reaching this bay. Instead, the iron bow plating remained coherent and tightly fastened to the forward structure, and the massive wooden bowsprit remained visible and largely associated with it. Looking upward from the main deck level, the remote optical cameras and sonar records showed the masts still associated with the wreck, though damaged. Their condition did not fit the simplest image of a ship completely torn apart before sinking. But the exact mechanism of that damage remains unresolved, and it should not be reduced to a single cause without further archaeological analysis. Taken together, the missing crush signature and coherent exterior profile became a major structural clue. They challenged the accepted image of a violent ice death at the abandonment site and supported the conclusion that the hull reached the seafloor with much of its structural cohesion intact. But the exterior geometry also set the analytical limit. The missing crush zone showed what the wreck was not: the obvious remains of a ship shattered by ice. It did not prove the final cause of sinking. Without a catastrophic breach, severed hull section, or wide crush field to analyze, the exterior sensors could not determine whether the loss came from slow flooding, a sudden but subtle failure, human action, or another process hidden inside the preserved structure. The missing exterior damage therefore forced a narrower but more powerful conclusion. HMS Terror did not leave the broad destruction signature expected from the old ice crush scenario. The wreck had changed the question from where it sank to how it remained so coherent when it did. The 2019 survey achieved a major non-intrusive condition assessment of the submerged vessel. The engineering team proved it could master the wreck's complex geometry and capture detailed visual intelligence without disturbing the fragile historical fabric. But the same framework that allowed the diagnostic mission also defined the next boundary. Preservation of the resting site would take priority over rapid physical extraction. The operational statistics show the scale of that achievement. Remote pilots established clear visual coverage of over 90% of the lower deck and generated a major repository of baseline structural data. They recorded bulkheads, maritime equipment, crew accommodations, storage areas, officer cabins, and personal possessions in their found positions, satisfying the core objective to document the vessel's interior condition. The defining legacy of the operation was Restraint, The team recovered exactly 0 physical artifacts from HMS Terror. Ceramics, scientific instruments, and the commanding officer's sealed wooden desk remained in place because the mission stopped at visual documentation, not salvage recovery. Today, general public access is not open without authorization, and unauthorized entry into the protected areas remains prohibited. Future access depends on a stringent authorization process shaped by Parks Canada and Inuit management. Monitoring and research now focus on currents, ice, climate change, biological risks, and the long-term stability of the wooden structures, with the goal of keeping the ship as stable and well-preserved as possible. While there is a globally recognized scientific desire to eventually investigate possible written records, any physical intrusion in the deep stern cabins is currently deferred. Before a specialized physical excavation could ever proceed, the operational teams would have to prove that exposing or recovering fragile paper would not compromise the surrounding historic site. They would need a jointly approved operational plan that protects the surrounding ship structure and respects the cultural and legal framework around the wreck. The overall outcome of the remote diagnostic mission stands as a highly definitive partial success. The deep water engineers and archaeologists located the lost vessel, demonstrated its extraordinary structural condition, and meticulously mapped much of its internal architecture. They secured a detailed physical record of the historic ship for future generations. Yet the ultimate historical proof, the detailed written timeline of the final days, remains a possibility rather than a confirmed object. The massive wooden vessel remains sitting upright in the freezing dark. It is legally protected, extensively mapped, largely untouched by intrusive work, and may still be guarding written evidence beneath a blanket of silt.